These are your 3-1B notes on graphing linear equations, and then also we're going to learn in this section not only how to graph using a table of values, but also how to determine if it's a linear equation or not, and then put these equations in standard form. So 3 major concepts there. So the first one we're going to talk about is what a linear equation is. A linear equation is an equation that forms a line when it is graphed. Makes sense. Linear has line in its name. You might think that those are the only type of equations there are, but there's a lot of other equations out there that do not graph lines. They graph more curved figures. So the first of which, the simplest, is linear equations. So in order for an equation to be a linear equation, there's some criteria. Just by looking at the equation, if the exponents of x and y are 1, it could be linear, but it has to be 1. So if they're anything other than 1, then it will not graph a line. The variables cannot be in the denominator. When the variables are in the denominator, it graphs a whole different thing. It will not be a line. And the variables cannot be multiplied together. If they're multiplied together, it will also create some crazy curve that will not be a line. So this is the criteria to determine whether or not you're looking at an equation and it'll graph a line or not. Standard form is just one particular way to arrange the variables and numbers for a linear equation. There's lots of standard form equations for different types of equations that we'll graph. So there's standard form for linear equations, quadratic equations, exponential equations, which we're going to study throughout the year. So standard is just a set of rules, a certain way to write the variables and the numbers of a linear equation. And for a line, it's the form ax plus by equal to c. So it's just an order. Okay, now just because it's not in that order doesn't mean it's a line, but we want to put it in this order, and then we know that we're talking about the same line. So if I let you guys put these lines in any order you wanted, I'd have several answers every time to have to read off. There's an infinite different ways to write one line. So by having a standard, it allows us to say, okay, we're all talking about the same thing. So I want to mention this a value here is a number, the b value here is a number, and the c value represents a number. The a value is the number of x. It's your coefficient of x. The b number is the coefficient of y. And then the c number is the leftover number that isn't attached to an x or a y. So we put the x and the y on the same side of the equation, and then we put the number on the other side. Okay, it's not my rule, it's just the standard of mathematics. Now, in addition to putting the numbers in that order, that's the very first thing. So to check to make sure that it's in standard form, there's several things that we're going to be looking for. Not only does it have to be in that particular order, so the x value has to be first, added or subtracted from the y value, equal to some number. Some people ask, well, can the x and the y be in a different order? No, not if it says standard form. So the very first thing you have to check for is the equation written in the right order. The second thing that has to happen in standard form is they want the a value to be positive. So this has to be a positive whole number. No fractions, no decimals, has to be positive, and it has to be a whole number, okay, or integer. Positive integer is a better way of saying that. B has to be an integer. Now, it can be positive, it can be negative, but it has to be an integer. So again, no fractions, no decimals, but it can be positive and it can be negative. And then the last thing we look for are the numbers a, b, and c in simplest form. And I'm going to give you an example for that so you can see what I'm talking about. If I have 2x plus 4y equals 8, I have all the numbers in the right order. A is positive. My a value is 2. My b value of positive 4 is a whole number. Everything's whole numbers. But I notice a pattern here. 2, 4, and 8. If I divided both sides by 2, every term, I could simplify that into x plus 2y equals 4. So the last thing we're talking about is it written in simplest form? Could I take a common number out of each side that would reduce that simplest form? All right, so first practice here is I'm telling you to put the linear equations in standard form. I'm telling you they're linear. So if they're linear, you can put it in that form. It's just a matter of getting creative or not. So the first thing I usually tell kids to do is to get it in the right order. So I want to have my x and my y value on the same side and my number on the other side. So if I have to move something, I use inverse operations like we did in chapter 2. So I notice that I want this 2x to show up over here with the y. So to make something move across the equal sign like that, I need to subtract a 2x from both sides. When I do that, I want that out in front, negative 2x plus 3y equals 4, okay? I understand that my a value is negative. It's a negative 2, and that's okay. I'm going to write it down, get the order correct, and then I'll fix it. So they're all whole numbers. That's good. The only thing I have to do is change the sign of every number. But since this a value here is negative, I need to flip its sign. So really what I can do is multiply both sides by -1. But all that really is just going to change this to a positive, make this a negative, and make my 4 a negative. So the math behind that step is that I multiplied this side by a -1 and distributed it. Whatever you do to one side, you do to the other. But I don't need to show that, okay? I want you guys to understand when we multiply by a 1, all the numbers themselves stay the same. The only thing that changes is the sign. So I don't need to see multiply by -1, multiply by -1, or divide by -1, divide by -1 would give us the same results. So I'm going to go through my checklist. I'm in the right order, A, B, and C. My A value is a positive 2. My B value is a -3, which is fine. They're whole numbers. Everybody's whole numbers. And there's not a number I can take out of a 2, a -3, and a -4. So it's in standard form. The second example here, I need to get this -2y to come over with this x. So I'm going to add 2y to both sides. I can't combine a 4x and a 2y, so I just write the 4x out in front, put the ax out in front, plus 2y equals 6. Now I'm in the right order. A is positive, B is a whole number, A and B are both whole numbers, but I do see a 4, a 2, and a 6 here, which means I could divide both sides by 2. Now, if I'm dividing both sides by 2, everybody's going to get divided by 2. So I just split it up for those two terms on the left-hand side. So my 4x becomes a 2x, my 2y becomes a 1y, and my 6 divided by 2 becomes a 3. If I go through my checklist, everything now works. Number 3, numbers are a little small. They're in the right order, but I don't have a whole number. So to make a decimal a whole number, I can multiply both sides by a multiple of 10. Since I only need to move the decimal one place, I only need to multiply by 10. If I need to move the decimal 2 place values, I need to multiply by 100. If I have to move it 3 decimal places, I have to multiply by 1,000. So multiplication of 10, you can actually put it in your calculator, or what you're going to find out is every single one of these is going to move over 1 decimal place. So my 1.2x is going to turn into 12x. My -3y is going to turn into -30y. And my 7.2 is going to turn into 72. Now all my numbers are whole numbers. A is positive, B is a whole number, and C is a whole number. But I notice when I multiplied by 10, I made everything 10 times bigger, but I probably could reduce that a little bit. I notice I have a 12, a 30, and a 72. I know that 2 goes into all of those. So if I divide each term in half, I'll end up with 6x minus 15y is equal to 36. And actually, I didn't divide by enough. So actually, I need to divide that again. If I divide this by 3, I'll get 2x minus 5y is equal to 12. So I just showed you how you can fix your mistake. I looked at 12, 30, and 72. I thought 2 was the only number that could go into them. It wasn't. Actually, I should have taken a 6 out from the very beginning, but I just took the extra 3 out later on. Okay, so no harm, no foul, just a little bit extra work because I didn't divide by the biggest number. If you look at number 4 here, number 4, I need to bring this 5y over here. So I'm going to subtract 5y. And I'll get negative 8x, and I'm going to worry about that later, minus 5y plus 10 equals 0, because the 5y and the negative 5y cancel. I need to bring the positive 10 over to the other side, so I'm going to subtract 10. So negative 8x minus 5y is equal to negative 10. And now what I need to do is just make my a value positive, so switch the sign of everybody. So my negative 8x becomes positive, my negative 5y becomes positive 5y, and my negative 10 becomes positive 10. That's all I can do there. For number 5, I'm missing an x value. We can add 7 to both sides. And so I'm left with 4y equals 7. And since I'm adding, I don't have an x value, I'm just going to simply bring it in. The only number I can add without actually changing the value of this is 0. So I'm just going to put in there that I have 0 x's. So my answer in standard form is 0x plus 4y equals 7. And there you have it. So there's nothing that says you're missing a variable. You have to have both variables. There's nothing that says that in the definition of a linear equation. In fact, this tells me that I only have one variable. My line is going to only move in one direction. It will not be a diagonal line. This line will be a horizontal line. So when you're missing one of your variables, you're missing one of your directions. You'll either have a vertical or a horizontal line. That's all that means. Okay, this part is going to ask us to determine if things are linear or not. So we're going to look at our checklist of linear again, just to review. In order to be linear, our exponents of x and y, if we have an x and y, have to be 1. They can't be in the denominator. The variables cannot be in the denominator. And they cannot be multiplied together. So if you look at the first one here, I've got x to the first. When we don't have it listed, it's to the first power, and y to the first. And nothing's being multiplied together. So this is a line, and so it says, if it is, put it in standard form. So I'm just going to rearrange this. I'm going to subtract 4x from both sides. Negative 4x plus y is equal to negative 5. And the only other thing I have to do is make that positive, make my y negative, and make my 5 positive. You might want to have your notes out because there's a couple different lists. There's a checklist for linear. Is it linear, yes or no? And there's a different checklist for standard. Number 7 is not linear because of this x and y are being multiplied together. Not linear. And so I can just say variables are multiplied together. So whenever it's not, they're going to ask you to say why. Whenever it is, they're most likely going to ask you to put it in standard form. Number 8 wasn't really in the checklist, but it's not linear because you have a third variable. In order to have a line, you can only have x and y because we have an x and y coordinate system. So z is 3-dimensional. This is not a line. So too many variables. We have 3 variables. When you're in 3 variables, you're in 3-dimensional. So the z is throwing us off here. Number 9 is linear. I know that we have a fraction, but I want you to understand that when you have a fraction number, the variable itself is rarely on top. So we have a fraction, but that's okay. The variable was not in the denominator, just the 4 was in the denominator. So I'm going to put this in standard form by subtracting y. 3/4 x minus y is equal to 8. And then I can't leave it that way. I'm in the right order, but my a value is not a whole number. So it's 3/4. To make that bigger, to be a whole number, I'm going to multiply both sides by 4. Whatever I do to one side, I have to do to the other. And when I distribute the 4 through, I end up with 3x minus 4y is equal to 32. And when I look at this 3, 4, and 32, nothing I can take out of all three of those terms. We're in the right order. A is positive, A and B are whole numbers. We're good to go. Number 10, 2x is equal to 5. It passes the line test because it has an exponent of 1. I know there's no y value, but that's okay. Nothing's in the denominator, nothing's being multiplied together. And in fact, to put that in standard form, we simply just have to add a 0y to it. 2x plus 0y is equal to 5. And so we're done. This line would be a vertical line. We only have one variable, we have one motion, it would be vertical. Last thing we have to do, here is just talk about graphing these things. And we're going to talk about several different ways to graph lines, but the first of the many ways is by using a table of values. So you're going to make a t-table. The reason we call it a t-table, that looks like a little lowercase t. One side represents our x coordinates, the other represents our y coordinates. When you use a t-table, you get to select any real number for the x value. You have a choice for the x value. You replace that x value into the equation. So a good three numbers a lot of times are 1, 0, -1, just right around the x and y axis. You take those values, you plug them into an equation, you figure out the equation, and it will spit out your new y values. You do not get to come up with the y values. The equation will decide the y values for you. You repeat this process for at least 3 times so that you have at least 3 ordered pairs. You can have more than that. We connect and extend these points. And when we connect and extend, we are basically writing and drawing every single ordered pair that makes a solution to that equation. So when we make our table of values, we're going to use these 3 lines to help guide us for all of these lines. And when you graph all of the ordered pairs that make that equation true, there's an infinite supply of those ordered pairs. It becomes a continuous line. So we connect and extend beyond those 3. You may have picked these 3 ordered pairs to make your line. Somebody else may have picked these 3 ordered pairs. So by connecting and extending, we're including all of those ordered pairs, even the fractions and decimals, rational and ugly irrational numbers. So let's try this. Y is equal to 2x plus 1. Actually, I think that is your example practice problem, so I'm going to let you keep that grid there. Let's go ahead with number 2. So for number 2, it's easiest to do a table of values since we want to know what y is equal to. Since we're coming up with the x value, it's best to get this in terms of y. So before I begin, I'm going to take this 3x minus y equation and solve for y like we did back in chapter 2. So to get y by itself, I'm going to subtract 3x from both sides. Negative y is equal to 4 minus 3x. And then I just want to change the sign of everybody. I want a positive y value, which will make a negative 4 value, and a positive 3x. Now that I have my equation set up for y equals, whatever x value I plug in, I know what y will equal, because I can just plug it in to this equation right here. So I'm going to use 1, 0, and negative 1. So when I plug in 1, I'm plugging 1 into this x value. I'm multiplying it by 3, and then I'm subtracting 4. You can use your calculator for this, but make sure you use the right order of operations. So 1 times 3 is 3. When I add that to negative 4, I get negative 1. This becomes an ordered pair, and that's one of your solutions on that line. When I plug in 0, I plug 0 in for x. I replace x with 0. 3 times 0 is 0, plus a negative 4 is negative 4. So 0, negative 4 is also a solution of this equation. And last one, negative 1. When I plug in negative 1, I plug it into the equation, then the equation gives me my y value. I got to choose what numbers I wanted to plug in, but then the y value is chosen by the equation. So when I plug in negative 1 times 3 is negative 3, plus a negative 4 is negative 7. So negative 1, negative 7 is also on this line. Your 3 dots should line up in a straight line. We connect and go beyond, extend those lines. If I found any ordered pair on that line, they would work and be a solution to this equation. So your lesson summary is to tell me if the following is a linear equation. If it is, put it in standard form. If it's not, explain why not. And then I want you to graph the line y equals 2x plus 1 using a table of values. You can use your example 1 space for that. Good luck.